Okay, it's Major General Retired Bryan Watson. I'm out here again with ERDC in the Construction Engineering Research Laboratory of CERL. We've already talked about a lot of new improvements in construction that CERL is working on, but one of the areas that they're really beginning to explore is how can we reduce the load on the soldier at construction sites, and in some cases remove the soldier from harm's way. And obviously we're talking about the use of robotics in construction. And so Kevin, you want to talk us a little bit about this piece of equipment back here?
Absolutely. So what we have back here is a J8. It's very similar to the SMET, which is a multi-use Army platform that's supposed to be a very just general system where we can put whatever is needed on it. It can be used in combat situations, it can be used in construction situations.
Platform is a platform.
Platform is a platform, exactly. And a lot of what this team, RIO, or Robotics for Engineer Operations, does is it develops modular payloads to put on these different platforms. So right now we have two payloads right here. The front one is a laser scanner from one of our partners, Trimble, and that gets us a pretty good high-fidelity view of what the environment looks like. On the back, we have a cone penetrometer that's automated, and that's something that will give us ground strength ratings to know what type of vehicles are able to drive on certain areas. So that's just two of the examples, but you can also see on the front here, we have some additional sensors that we put on the system. We have custom compute hardware inside, and we have many, many different modules that we're developing. And the idea is, where can we get one of these modules that we can make sure that the engineers in the field have exactly what they need? So if they need to go out and build an environment, a map, we can say, okay, let's put our mapping payload on this, send it out into the field. If they need to say, okay, we know what's out there now. We've already built this model. We know where everything's supposed to go. Now we need to go affect the area where we're working on autonomous earth-moving operations. So that's taking something like an excavator or a compact track loader, and that's taking it, putting some compute on it, instrumenting it with sensors, and sending that into the field. So it's a bit of a start to finish operation of saying we can take one thing, put it out into the field, get an idea what's going on, come back, analyze that data, analyze what we're getting out of it, and let the human aspect saying, okay, let's look at this map, let's look at deliverables, and figure out exactly what we need to do where. And then we send out the system to do that.
Yeah. So, I mean, if you just look at the two pieces of equipment, the two payloads that we have on here now, I think about, let's say we're on a river crossing. I could take this piece of equipment down in, it's going to grab me a bunch of imagery, high-resolution imagery.
Yep.
It's going to help me map out that crossing site. It's going to be able to let me understand how much, what the strength of the ground is so that my ingress and egress routes, and I'm doing all of that. All that information is getting transmitted back, and now I can make decisions about how I'm going to attack this river.
Exactly. And so that touches on some interesting things, is we have different levels of autonomy with this too. So this can run in either complete autonomous mode, where we're like, hey, here's a general area, go and figure us out some information, or we can use waypoints of saying, we care about this egress point. We care about this area near the river, go get us a couple of data samples around here. Or we can teleoperate the system. With this, we've teleoperated over 3 kilometers before, just with one person with a small controller and a camera, and just doing their operations remotely. And that's one thing that's really important for us, is getting that engineer out of, the warfighter out of harm's way. While this system is expensive, it's not as expensive as a human.
Yeah.
Training and a human life, that's hard.
Yeah, and it's not only saving lives, but it's also reducing the load on the soldier. So if I think about, another scenario, maybe I've got to build a base camp. I know that base camp is going to have some sort of UAS airstrip. I could use this piece of equipment, say, I'm thinking in the context of this base, I'm going to put the airstrip in here. Now tell me the exact best place. It goes out, it figures out the ground and how strong it is, gets me the imagery I need. I can begin to look at, what kind of flight obstacles I might have. All that done right here.
Exactly.
Yeah. That's fantastic. So, hey, Kevin, I appreciate very much what you guys are doing for my profession, and everything that ERDC does. You really are capturing our imagination.
Awesome. Thank you so much for your questions and input. It's always great to have a conversation with you.
Good.